This is video help on homework 9, chapter 21, and we're looking at problem 3 on the back page. It's the third problem at the end of the chapter 21. And what it describes is a lead bullet rotating about an axis this way. We're approximating the bullet as a cylinder of diameter 0.22, making the radius 0.11. The length of that from here to there is 1 inch. The frequency of rotation about that axis is 3,000 revolutions per minute, and of course you'll want to convert that over to MKS, and that means revolutions per second for the frequency. Also from that you can get the rotational velocity omega, which is 2 pi f, and remember that 2 pi is 2 pi radians per rev in this equation right here. Then use the frequency from up there. That's part of the information or the value that you need to figure out the two things that are being asked for. The first one here is the moment of inertia I, and then the angular momentum L, like this. Let's go for the I first of all. What you'll need to do is figure out that for a shape like a disc or a long cylinder with the axis of rotation through the middle like this, the moment of inertia is 1/2 mr squared. Now you already have the radius right here, but now we need to figure out what the mass is that we plug in right there. They don't really give you the mass in the word problem, so we'll have to calculate it from the density. The density rho is equal to m divided by v. Sorry for the noises in the background, an active day up here in the physics department. Alright, so solving for m, you get rho times v. If you look at the density of lead, you find out that if you look it up online right here, you see that it is about 0.410 lbm, pound masses that is, lbm per inches cubed. That means if you took a 1 inch by 1 inch by 1 inch cube, it would weigh 4/10 of a pound. So fairly dense material that we're referring to here. Solving for the mass right here, you see that you would take the density times the volume. You can put in a number for that right there. And recall that the volume of a cylinder, is let's see, pi r squared times L. So you take the surface area of this and extrude it into the third dimension. So area times length is going to give you the volume of that cylinder right there. It looks like you have all the numbers for this. R is right here, L is right there, but yeah, I think that's it. That would allow you to get the mass of this, and the units, if you work it out, is lbm. Now of course you want to fill in the steps here. There's several things you want to do is put in the numbers with units, and at the very end you would get a number measured in pound masses. At that point then you could say that I is equal to 1/2 mr squared. And then you're going to get an answer after you do your parentheses and so forth. You know what I mean. 1/2 and this right here squared. And I think you'll have to do one more conversion here in order to get it from inches right here into feet over here. I believe that's going to be feet squared in the case of the units for capital I. Then remember that the definition of angular momentum of a solid rotating body is simply I times omega. Do your unit analysis, make sure that everything works out, and remember that you can drop the radian at the end so that your units turn out to be pound mass, feet square per second.